Hey everybody, it's the T2sday. It's time for the T2sday update. Unfortunately for Samter and all of us, I have no videos to show this time. Oh, and I also don't have enough light on the subject there. How about that? No Beevee at the moment and so forth. I decided I would just try to do a regular talk as if I was still an academic. And the title of the talk is T2.5 tile. That is in quotes. Those are scare quotes to warn us off that there's something shifty about that name. So, okay. My feeling is that every proper talk should begin with the creation of the universe and work its way forward to what just happened, moments ago. So I'm going to start with some background. The folks, long-time T2 Tile project folks, this will probably not be much new, but hopefully it'll be fun anyway. Then eventually get to specifically what I did in June while I was failing to produce any new Beevee videos, in particular talking about the T2.5 tile, what my ideas for that are, and then the goals for next month. So I have had a mission in life ever since before I was conscious that I like to make things, do things by themselves. So the goal is make something, do something by itself. And I did that with toys and blocks and all kinds of things as a kid. And in high school, I found a computer. Our computer had a high school. Our high school had a computer, which was quite something back in the 70s, and we hacked our brains out on it. It was really wonderful. I went to college, still did all kinds of computers, went to graduate school, did all kinds of computers. So in the 1980s, I was doing machine learning, this connectionist approach, which at the time was all like radical, and artificial intelligence was not this, whereas of course today the connectionism has completely won, so much so that the word is barely used anymore, but that was then, and that was great and that was fun. In the 90s I started to shift from artificial intelligence, as we thought about it, to artificial life, and the main reason that I would tell myself is that it seems to me if you're trying to predict what an organism is going to do, or what I'm going to do in any moment of any day, you can probably get a lot more leverage out of the fact that I am a living organism than the fact that I am an intelligent organism. And so did a bunch of stuff exploring artificial life, and that was great. It was lots of fun. It's a great community. And that led to the 2000s, to the new millennium, when this collision between livingness and computationness smashed into each other in my mind so many times that it became living computation. And the essential idea of living computation is that living systems and computational systems turn out to be the same thing. Living systems and computer systems are going to be the same thing, and they may not seem that way now because we think about them in sort of limited, restricted ways. But if we understand them more generally in their more fullness, we will see that they go hand in hand, two sides of the same coin, that sort of thing. So on social media, I am living computation, and all of this stuff that we're now doing is being supported by the Living Computation Foundation, which you could become a Living Computation Foundation nerd if you have a little bit of spare change. And then in 2018, I started the T2 Tile project, a YouTube channel. This is the title card of the pilot episode, the first one. Notice it is episode number 10, status report number 10, not 1 or 0. So that's a little red flag that there's something weird going on about the episode numbering. But be that as it may. And the key part of that original pilot was this this idea that if I'm saying we need a whole new kind of a computer architecture that's very different than CPU and RAM, and it gives up a lot of the stuff that we really like about CPU and RAM, and in particular, it gives up complete predictability. It gives up complete repeatability. And, why would anybody do that? And so, yes, we say this is a hard pill to swallow, but it's going to give us great abilities down the road if we can just do it. So why would anybody believe me? Nobody should believe me. That's an extraordinary claim. So the idea is, let's just build it. And that's what I've been doing ever since. Enough so that by 2023, there is a wall of these tiles that are individually running little cellular automata, a particular kind of cellular automata, and then also connecting to its 6 nearest neighbors, if there are 6, so that the computation can spread. It's not limited to one particular set of machines. And from there, in 2024, last year, the thing about the projects that I had been doing previous to this was that they all were completely internal within the matrix, and I was interested in exploring what would it be like if the T2 matrix, the program that was running on it, cellular automata running on it, needed to interact with something that was outside the matrix. And so I wanted to do a robotic thing. Now, the T2 tiles are incredible. They're wonderful. I love them. They're my children, but they're really, really slow. And that was deliberate. That was my focus on the hardware design, software design, all of it was to be as conservative as possible, focus on doing something that had the best shot of working. And I kind of did get it to work pretty well. But as a consequence, it was very, very slow. So days and weeks and sometimes months to gather a long-running simulation. So there was no way I could have a real robot that was going to connect to this thing. But we made up Beevee, the simulated robot that was going to be controlled by the cellular automata. Why is it called Beevee? Because it's inspired by VB. It's inspired by Valentino Breitenberg, a psychologist who studied these very simple control mechanisms, which is in fact what Beevee first implemented before moving on. And that brings us to today. So what happened in 2025? I want to talk about this T2.5 tile idea. So I talked about the T2 tiles being slow, and that is, from the point of view of just doing a demo and then showing it in time lapse, speeding it up so that days and weeks and months become minutes, seconds and minutes, I'm okay with that because especially given that, the whole thing is so brand new, it's unclear how we were going to build any of these things. And know a ton more about how to build this kind of stuff, how to program this kind of stuff than we did 5 years ago or 7 years ago. Oh my God, 2018 was 7 years ago. But the fact that it's so slow means that there's just a practical limit on how big the code can get, because it gets slower and slower. The bigger the things that you build are, slower and slower, because, the signals have to propagate through this big object. The bigger the object gets, the longer it takes for signals to get all the way through it. And so the longer it takes to get to where the bug happens. And so the whole edit loop to develop the code gets slower and slower and slower. So the idea was, let's take one of these new computers that's coming out in the age of AI, when the goal is to mostly be able to do matrix multiplications, multiply a matrix by a vector, multiply the weights by the states, add them up. The stuff I did in the 80s that has now changed the world, and for good and for ill, and who knows exactly where it's all going to go. But as a result of that, and I'm going to skip the part about, everybody tells me, you should use GPUs to do this. And I understand that people saying that because GPUs are the poster child for parallel, do a whole bunch of stuff in parallel. The problem is for the particular architecture I've got, the movable feast machine, it needs to be able to do different things at the same time, whereas GPUs excel at doing the same thing on a whole bunches of different data at the same time. And they're really not well suited to the kind of architecture I was using. But amongst these new architectures that are coming out, there's one from a startup, I mean, it's been around for quite a while, called TensTorrent, that is building parallel machines with hundreds of little cores in them that can all do different things at the same time. So in my simulations, I have all these different elements that are cellular automata that have different behaviors. And depending on which one is having an event, you have to run different code. And so I've been ramping up on Black Hole. I talked about it last month, the foundation, because we had a wonderful donor who came forward with a pile of money for us to do this. The Living Computation Foundation put it in order for a $12,000 machine called the TensTorrent Blackhole Quietbox that's going to have 4 of these black hole cards in it and hundreds, like almost 500 of these complicated cores with lots of power in them and so on and so forth. The underlying cores, it's really a lot of complicated, a lot of hardware. But the cores that I'm going to be focusing on inside the black hole chips are RISCV, which is a very simple, relatively new, comes out of UC Berkeley, University of California, Berkeley. They've done tons of great stuff. And the important point about RISC-V is that it's open source so that anybody can build on it. They have, conformance tests to make sure it doesn't get screwed up. So in June, I spent a lot of time reading a lot of stuff. Wow. And that's not what what's the very next thing. In addition, Beevee returning to the Matrix. All right, let's push on. Since I pushed with my elbow. So in the T2 tile, there's, it's a complete architecture for cellular automata. Like I said, it's a very weird one, but it has all of these parameters, which I collectively, about, I guess, a decade ago, called the P3 parameters, because they were the third major set I had explored, that have all these things. It's, there's each atom, the fundamental unit of the cellular automata has 96 bits, which is a ton compared to typical cellular automata. Well, it's varied these days. And so on and so forth, all these things. And now for this T2.5 tile, I'm not calling it a T3 tile because we're not going to be building an indefinitely scalable array of them, at least not at first, because we're just going to build whatever it takes to use the TensTorrent Blackhole Quietbox as effectively as possible to do lots and lots of events, but to do them fast enough that we'll be able to interact with it. We'll be able to see it moving around rather than having to do time-lapse all the time. The atom is, I'm bumping the atom size up to 128 bits because 128 bits is kind of the fundamental granularity of black hole. It just moves things in terms of 128 bits all over the place. So let's do it. In the P3 parameters, you could have 65,000 different types of elements. Like the periodic table of the P3 atom could have 65,000 squares in it. And I never came anywhere close to using that, and I never would be able to because it would get so incredibly slow to do it all. So I'm cutting that way back to 512 elements, and we haven't gotten close to that yet. We've gotten a couple hundred, so it's comfortable, but it's not not ridiculous. And the important point is that there used to be 71 bits available for the programmer. Now there are 112 bits, almost a 50% bump. All right, Beevee returning to the T2 matrix. Here it is happening. Project Beevee 2025, that's the new code. Here, Beevee brain, gray and green. That was an old Beevee that was running from code that was running last year. And this is when I've just plugged in the new machine and it's starting to spread through it, but it doesn't work. This was just another fun little picture showing these black and red wires here are serial lines that connect certain tiles to the controlling computer, which is where the simulated robot is running. But there's a problem in the brain, so that's going to have to be debugged next month. In addition, I started working on rewrites for the living computation theory of everything. That started out as a video on the Dave Ackley channel. I'll put a link into it. Everybody should watch it if they haven't already seen it. But now we're turning it into an essay that's going to be part of these collected works of the Living Computation Foundation. And I had struggled a little bit to get it going, but friends are helping out and doing a lot of the formatting and getting it cleaned up based on a transcript of 2020 revised for this upcoming book. And so I've managed to get going in it, so it makes me feel cautiously helpful. So, this is what I was supposed to get done. Beevee on the T2 matrix is on its way, isn't there? Ulam 6 release, I completely failed at. Quietbox site planning, a little bit. Have big fun. Yeah, I had a lot of fun. And this is my set of goals for next month. So during July, get the electrical stuff set up. I'm just chicking about I'm not going to do it myself, but just getting out and getting an electrician in here. Try to have P4, teeny tiny little P4 spike, not anything general, not any big language, just some little teeny events, just so I can see that maybe it can work and have lots of big fun. And that's it. Thank you so much for listening to whatever fraction of this you happen to listen to. If you didn't listen all the way to the end, then you don't get thanked. But I still thank you for listening to whatever it is. And I hope to see you next time.